Let's look at graphing the next question here. You'll notice that this is not in factored form. So for us to graph this, we need to find the x-intercepts. To find the x-intercepts, we need to factor it. That's why when we put that y to 0. So let's factor this. I'm going to take out a GCF just to make that a little bit easier. So we can factor out a -2. So we get x cubed minus 3x plus 2 now. So to factor our x cubed, it's cubic. We need to test points to find factors of 2. So I'm going to test a point. I'm going to see if 1 works. I'm going to test x equals 1 to see if I get a remainder of 0. 1 cubed minus 3 times 1 plus 2. So 1 minus 3 plus 2, -2 plus 2, we get 0. Therefore, x minus 1 is a factor. So let's use our synthetic division now. So we're going to use 1 as the divisor. Plugging in this, keeping in mind that we need a placeholder for the x squared. So we need that 0 in there. So we have 1, 0, -3, and 2. We're going to do our synthetic division. So remember, multiply, then add. 1 times 1, multiply, then add. Multiply, then add. You know you're on the right track because you got your remainder of 0. So we get x squared plus x minus 2. Keeping in mind, x minus 1 is still a factor. Let's continue to factor that. So when we factor this further, we're going to get x plus 2, x minus 1. So these are my factors. So because we're going to be solving for the x-intercepts, I want to make sure that I clearly have my equation. This doesn't just this has to turn back into an equation. Now let's solve for the x-intercepts by plugging in. Let's make sure we know we're doing that. So we plugged in 0 for y. So we have x equals 1, -2, and 1. Okay, let's find the y-intercept. You can either use the factored equation or the equation that was not factored. Just going to adjust the camera there. It makes more sense to use the original question because then you've got your constant term right there. So if I plugged in 0 for x right away, y would equal -4. I'd get the same result if I used the factored equation, but that's all easier. Now, this is a cubic function, so we know that it's odd behavior, so the arrowheads are going to go in opposite directions. Because it's negative, instead of it falling left, rising right, it's going to be reflected, so it's going to be the opposite. So that means it's going to rise to the left and fall right. So let's put in what we know and see what else we need to do. So x-intercepts, 1, -2, and just 1, and these are double roots. So we'll talk about the double root where we bounce off the x-axis. Okay, end behavior, rises to the left. So my last x-intercept, I want to go this way. Falls to the right, I want to go this way. I want my y-intercept in there. Y-intercept is -4. This makes sense because this has to bounce. It's going to connect there. And again, as a quick sketch, I could just connect this. I like to be a little more accurate, so I'm going to test x equals -1 because that's easy enough to do. So test x equals -1. I can either put the equation, the -1 value into this formula, or equation, or the factored equation. It's not going to make a difference. So if we go -2, let's say we chose the factored equation here, -1 minus 1 squared, and -1 plus 2. So we're going to get -2. This is -2 squared, and then this is going to be 1. So we get y equals -8. So it was, -1 and -8. So it was a good idea that we tested those points because then it does go down further than maybe I originally thought. So it was worthwhile testing to get a little bit more of an accurate graph.